Hello and welcome for the final talk on day 2 of Polkadot Decoded. And many of you know already about Substrate and Polkadot, and Substrate being the way of building blockchains and parachains on Polkadot, and also being the actual nodes that people run on to run the Polkadot network. This has all been built in Rust by Parity Technologies, but as we've learned from other blockchains, it's really beneficial to have multiple implementations in different languages. So with that, I'd really like to introduce you to Liz Binks from ChainSafe, building Gossamer, and she'll be doing a workshop on how to build a blockchain with Gossamer.
Awesome. Thank you, Phil. Cool. So yeah, thanks everyone for coming to my workshop. So today I'll be talking about Gossamer. So to start off, I'll introduce myself. So I'm Elizabeth. I am working at ChainSafe Systems on the Gossamer project. I'm currently the tech lead on the Gossamer project, and I've been working on it since it started, which is around almost 2.5 years ago, slightly over 2 years. When we got a grant from the Web3 Foundation to build an alternative implementation of the Polkadot host. So to start, I'll just introduce what Gossamer is. And for this workshop, you can follow along as well with this document, which I believe should hopefully be posted in the chat by my teammate Dustin. So let me know if you can't access it or anything like that. Cool. So to start off, so what is Gossamer exactly? So since you're at Polkadot Decoded, you've probably heard of Substrate and Polkadot. So Substrate is the blockchain framework that was used to build Polkadot and Gossamer and all the other network nodes. So Substrate provides all the basic blockchain functionality that you need, so networking, state, consensus, and more. So Gossamer is the Go implementation of the Polkadot host, so it aims to be equivalent to Substrate in terms of what functionality it provides, except all just written in Go instead of Rust. So the two main functions that the Polkadot host has is firstly to create your own custom chain. So the first is just import a runtime with custom logic and just simply launch your chain easily. And then the second function is to be able to create a chain that's compatible with the Polkadot ecosystem. So to create not only a standalone chain, but a chain that could become a parachain eventually. Cool. So the current status of Gossamer is that we are interoperable with Substrate nodes. So earlier this year, we were able to sync fully with the Polkadot and Gossamer networks. So yeah, we are happy to say we are Gossamer can act as a Polkadot or Gossamer full node, and it's currently compatible as well with existing tooling like Polkadot.js. So in terms of future plans for Gossamer, we're currently our current next goal is to interoperate with Polkadot and Substrate in general as an authority node. So we do have the authority functionality implemented, but we need to still fully test that it interoperates with Substrate nodes. So we're currently running an internal Gossamer DevNet to test all the functionality between Gossamer nodes. And then once that's done, we plan to run a cross-client DevNet, so with Gossamer and Substrate nodes, so that we know that the authority functionality works and there's no issues with that. Cool. And then just a little aside as well. So a Polkadot host can't become a parachain on its own. It requires this additional building block or additional kind of connector piece called Cumulus. So Parity has written the initial implementation called Cumulus, which will be used to connect parachains to the relay chain. So recently, ChainSafe got another grant to build a Go version of this, so Go Cumulus. So in the future, we hope for that that Gossamer and Go Cumulus will be, nodes built with Gossamer and Go Cumulus will be able to act as parachains as well. So that's exciting. Cool. Okay. So for today, for the workshop, I'll be going over firstly how to import a runtime into Gossamer. Secondly, how to launch and start your chain with this custom runtime. Thirdly, how to interact with the chain using the existing tooling with Polkadot.js. How to run a non-authority node locally and just connect and sync with your local development node. And then lastly, I'll just show briefly how to start and run a Kusama or Polkadot full node. Cool. Okay, so for prerequisites, if you want to follow along, you'll need Go, 1.15 preferably, and then Node.js as well for the Polkadot.js portion of this. Cool. Okay, so to build Gossamer, you can simply clone it and make it. So I already have it on my computer, so I'm not going to do that. I'll simply go to my Gossamer directory and then make sure I'm on development. Okay, cool. And then make Gossamer. So yeah, I'm just going to build Gossamer now. And then when this is done, it'll place the binary in the bin directory. Yeah, so you can see it's bin Gossamer. Cool. All right, so importing a runtime. So firstly, before you import a runtime, you have to obtain your runtime that you're going to use. So custom runtimes are built generally using Frame, which is a domain-specific language that exists as part of Substrate. So this is a language that you can use to create runtimes that fulfill the specific API that's needed by the host. So then once you build your runtime using Frame, it gets compiled into Wasm for use with a Polkadot host. So the API for the runtime looks like Babe block production, the authorities for Grandpa finality, a validate transaction function to validate incoming transactions from the network or from the RPC layer. And then you have these 4 functions, which are used for building a block. And then finally, execute block, which is used to sync a block that's coming in from the network. So just wanted to quickly go over that. It's not super relevant for runtime directory. So I will show you exactly what I changed in this runtime for use with Gossamer. So also if you want to try this on your own later, please try it with the v0.8 runtime. You'll soon be upgrading to v0.9, but for now, please use this v0.8 branch. Cool. Okay, so Substrate, I'm just gonna go to the runtime folder on Substrate. Okay, cool, and then I'll quickly just show the couple changes that I made to create a custom runtime. Okay, let me make this bigger. Cool. Okay, so the first thing I changed was just changing the name of the node. So here, this is the version data from the version call I showed earlier. So this is what's returned by that. It's just essentially the hard-coded version data of the runtime. So I just changed the name to Gossamer node before it was Substrate. And then the second thing I changed was the Babe Genesis configuration. So this is also hard-coded by the runtime. So the thing I changed was this C parameter. So what this is that, so the Babe block production algorithm has slots. So each slot, a producer may or may not be able to author a block. So the C value is the probability, so 1 minus this C value is the probability of a slot being empty. So for example, right now, this is 1. So this is actually a fraction. So then, so it's 1/1, which is 1, and then 1 minus 1 is 0. So there's a 0% probability of the slot being empty now if I set this to 1, 1. So if I set this to, previously it was set to 1/4. So that means there would be a 3/4 chance of a slot being empty. But since we're going to just do a development network, I'm going to set it so that, a block producer can claim a slot every time. Cool. Okay, so I will not show compiling this because it might take a while. So if you would like to download this and try it out, I have it uploaded here on my GitHub. If you want to try compiling it, you will need Rust. And please use this specific version and make sure to add the Wasm target. Cool. So this places the runtime in the substrate target directory, specifically, well, I'll show after, but it's kind of deep in there. So yeah, so it's this path that it places it in. Cool. Okay, so now that we have the runtime, so I'll show that it's substrate, target, WASM, release, wbuild, node runtime.wasm. Okay, cool. So I have it on my computer, so that's good. Cool. So what's it called? So creating the Genesis file. So I'm actually going to re-download this now just so I can have it quickly. So I'll just put it into desktop. Cool. Okay, make sure it's the right one. Awesome. Okay, so now that I have the runtime, I'm going to create the Genesis file using this. So the way that the runtime is set at Genesis, or set at any point in time, is by placing it in the state tree at a specific key. So this key is :code. So to set the runtime, you just place your compiled wasm binary into the state at this key. So this is also how runtime upgrades work. So the way the runtime upgrade works is that some transaction or something is submitted that updates the value at this :code key, and then the host will see that it changed and then change the runtime for the host. So cool. So I will now use this Gossamer subcommand import runtime to create a Genesis file. So Gossamer import runtime, and then I put it at where I put it. I think desktop, and then node runtime. Cool. Then I'll just output it into some demo genesis.json file. Cool. So awesome. Okay, I'm now gonna open this and I'll show you what's exactly in this Genesis file. So yeah, so there's quite a few things in the Genesis file. So firstly, it shows the name of your chain. You can change all these parameters as well. So the name of the chain, or sorry, this is the name of your node. This is the ID of your chain. Chain type, optional, boot nodes if you want to have boot nodes. The protocol ID for the networking layer. And then here are the authorities that are set at Genesis. So I currently have 9 babe authorities and 9 grandpa authorities set, also with pre-funded balances, as you can see here. Okay, so these keys here correspond to the built-in keys for substrate, like Alice, Bob, Charlie, etc. So a nice tidbit, I guess, that I'll show that's kind of nice for development is that if you use subkey, so subkey is a sort of sub-package, I think, of substrate that you can install. So subkey, if you do subkey inspect --Alice, for example, it shows Alice's private key, public key, and address. So the address here corresponds to the address that's in the Genesis file here. And Gossamer also has these keys built into it as well. Cool, so just a nice tidbit, I guess, for development. So I'm gonna modify this file since I don't need all 9 authorities because I'm just gonna be running one dev node. I'm just gonna get rid of all the other authorities. So I'm getting rid of the authorities. I'll leave the balances because it doesn't really make a huge difference. So cool, and then here's the system code section. So this very long hex string here is the actual compiled WASM binary of the runtime. So that's where it goes. And then here are some properties for the chain. So the address format, number of decimals to your token symbol, that kind of thing. Cool, okay, so awesome. So just make sure that's saved. Oops. Okay, and then I'll just get rid of that. All right, cool. So now the Genesis is ready. So I will simply start the node now. Cool. So first, to start off, I'm just going to initialize it. So with the init subcommand, it writes the initial Genesis data to the database. If you've never run the node before, it'll auto do this for you, but I'm just going to do it just to show you. So, and then I'll pass in the Genesis file as well. And then, yes, I want to reinitialize it. Okay. So cool, it initialized. And then I will just now run the node, and then I'm going to provide the Alice key. So the authority that I left in the Genesis file was the first address, which is Alice. And then I'm just going to provide the key to the node so that it can actually author blocks and do its thing. Cool. Okay, so node is starting. Okay, awesome. So node has now built the first block, second block, etc. Okay, cool. So node is building. You can see it's also finalizing blocks as well. Cool. Okay, so node is happy. Yay. Okay, cool. So if you are using Gossamer for development, all these previous steps that I've just done have been condensed for you into a chain dev option. So this will use the runtime that I just showed earlier, as well as the Genesis file. And then it also will use the config file found in the chain dev directory. So the config here. And then if you want to specify your own config, you can pass it with the config flag. Cool. So I'll just show using the dev chain. I'm gonna force initialize it. Okay, and then I will just start the dev chain. Okay. Okay, cool. It has started. Awesome. Okay, so now that we have the node running, I will show how to interact with it. Cool. So firstly, I have this JavaScript script here that you can use. So what this does is it does a transfer from Alice to Bob of this many Goss tokens. So I will show how this works. Cool. So I have this already in here. Let me just make sure I'm using the right node version. I'm going to use, okay, I'm now using the right node version. And yeah, if you want to try this, please use the 4.6 API. It's the most stable with this API version. Cool. Okay, so in this transfer.js, what does it do? So it first connects to the WebSockets, the WebSocket server that the Gossamer is running. So the dev node by default runs WebSockets. Where is it? Yeah, so by default it runs the WebSockets at 8546. You can change this in the config file if you want. So connects to the WebSockets, creates a new keyring, uses the Alice and Bob keys that I showed earlier. So, and then once it does that, queries the balance before, and then does the actual transfer, or yeah, signs and sends the transfer. Look at the transaction hash, and then this part subscribes to the new heads of the chain. So yeah, when a new block is triggered, it'll trigger this function. And then it should find the extrinsic, and then, find the extrinsic, and then log the balance after. Cool, so I'm just gonna run that now. Okay, cool. Okay, so that was nice and fast. So cool, so we can see this was the balances before, got the transaction hash, and the block, the transaction was in block 33. The balance has actually changed, so that's good. I guess I can also show some of the logging for Gossamer. So if I rerun this, but with the Babe logs turned on, or the Babe logs set to default, you'll be able to see the actual extrinsic, like the entire block as well as the extrinsic. So I'm just going to rerun that now with Babe at debug. Okay, so yeah, we can see a lot of debug logs. Okay, yeah, so you can see now that the entire block that it's building. So you can see the block has the parent hash, number, state root, extrinsic root, the digest, and then the actual body. Where is the body? Oh, okay, it's here once it's built. So yes, this is the actual body. So the empty blocks, well, empty just have this extrinsic timestamp, which is what this is. I'll show you on the UI after, but okay, cool. So I'm just going to rerun this, and then you should be able to see in the block that the full extrinsic is there. So this is kind of nice for debugging to see like what's going on. Okay, cool. So yeah, so this is block 53, and our extrinsic is in the block. So yeah, you can see that it applied this extrinsic, and the balance changed. So that's nice. Cool. So yeah, so there's a lot of things you can do with Polkadot.js. Object transfers you can call like any function that you would like in the runtime. So yeah, you can check out the docs, which are nice, at polkadotjs.org. Cool. Okay, so I'm now going to show using the UI. So so cool. So the UI is currently nice and stable with the 4.x, the 4.6.x version of the UI. Oh no. Oh, okay. Okay. Well, this is not good. Sorry. 1 second. I have the non-ChainSafe IO version of this. Okay. 1 second. I'm sorry about this. Okay. Pretty sure it's this. Okay, so it's fully down. That's not good. Okay. All right. Okay, well, sorry about this, everyone. I'm gonna okay. Hopefully I can show that later on in the presentation. Okay, well, sorry about that. Okay, so yeah. All right, I will just go on to the next part then for now. So yeah, I'll show just running a non-authority node and then syncing it to the existing node. So this is, yeah, so this will be nice for if you just want to, yeah, just like run a syncing node, don't want to run a full authority node. So essentially, you're gonna set, you're gonna run the node with the roles flag set to 1. So the roles flag specifies like the role of the node. So 0 is no network at all. 1 is a non-authority node, so just a full node. And then 4 is a node with authority functionality. So the dev node runs with roles 4 as default. So I'm going to show it with roles 1. So chain dev, roles 1, and then you have to also change the port. So the default libp2p port is 7001, so I'm just going to set it to 7002. And then also you can specify the base path, which is the where the database for the node is stored. So I obviously don't want to store it in the same one as the existing node, so I'm just going to put it in some temp folder. I don't know if this exists, I'll just do 0, and then that should be good. And then, and then I'll also add boot nodes as well. So since my nodes are both running locally, even if I don't specify the first node as a boot node, it'll eventually connect over MDNS, but I'm just gonna show it just to make things a bit quicker. Cool, so if you go to when your node starts, back up to the logs, you'll show that it prints out this started listening. And then this address here is the libp2p multi-address. So this is what the nodes use to address other nodes, essentially. So if I specify this with the boot nodes flag, it should connect to our first node and then start to sync. Cool. Okay, I think the UI is back up, so I'll show that after. Cool. Let me check. Oh, what happened? Oh, that's just the RPC. Okay, cool. So it's syncing now all the blocks. It's marking the blocks finalized too when it gets the ones that the first node finalized. So yeah, we're syncing now. That's good. Cool. So yeah, I should just go up to whatever this is, 137, 138-ish. I'll just wait till it's done. Should sync pretty quickly. Oops, okay. That's just a warn, not an error. We can ignore that. Cool, okay, so now our second node is nice and synced. That's nice. Cool, okay. So yeah, that's just kind of how you run just a syncing node. All right, so I think the UI is up now. Awesome, thanks team. Okay. Is it this one or is it this one? Okay, this one's. Oh, okay, here we go. Awesome. Okay, I'll make this a bit bigger too. What's going on? Okay, it's just kind of slow. Okay, cool. So yeah, I will show now connecting to the Gossamer node. So yeah, by default it's on Polkadot. So I think right now it's still trying to connect. Okay, yeah, so here we go. So it just connected to Polkadot. So by default you'll see all the Polkadot info, so the blocks, extrinsics, etc. I'll shut this down for now. Cool. So yeah, so to connect to the dev node, you'll go to this little sidebar here on the left, and then go down to development, and then local node, and then put in your custom endpoints. We had 8546. Okay, cool. So then hit reconnect, and then it should connect, hopefully. Make this a bit bigger too. Okay, cool. So yeah, so it looks like we have connected. We are getting the blocks. Okay, cool. So the blocks are showing up. Okay, sounds good. Okay, so let's go now to accounts. Okay, awesome. So yeah, so I guess I'll just go back to the blocks. So I'll just show, yeah, so you click on the block, it shows all the block info, that kind of thing. So yeah, I'm just going to show doing a transfer now with Gossamer. So yeah, so I have my pre-funded accounts here. So like I said earlier, like Alice, Bob, Charlie, etc. So I'm going to send some Goss I'll send it from Alice to Ferdy, I suppose. So yeah, so I have TGOS, which is trillion Goss. So I'll send one TGOS from Alice to Ferdy. Oh, okay, that's not supposed to happen. Okay, let me try that again. Okay, Okay. No. Okay. Let me try restarting the node. Maybe that'll work. This doesn't usually happen. Okay. Okay. Cool. Let's wait for this to restart. Make sure this is the right API. Okay, yeah, it is. All right, let's retry this. One TGOS from Alice DeFerdy. Okay, now it's working. Okay, that was weird. Okay, so looks like it worked now. Cool, so it's in a block. So yeah, we can see it was in block, what number was this? Block 6. Cool, and then yeah, then the balance got updated. So we can go back to the Explorer. You can see that there was this transfer event in block 6. So you can see, yeah, we can see all the details of this. So that's nice. Cool, okay, so yeah, so you can also do some other cool stuff as well with the Polkadot.js. So if I check out, yeah, so you can also submit whatever you want essentially. So I'm going to submit like some random hash as a proposal. Submit that. Okay, that didn't work. Okay. Never mind then. So, okay, cool. So, all right. Cool. So yeah, so that is essentially the UI. So yes, this is a self-hosted or hosted by ChainSafe UI pinned to the 4.6 API. So yeah, if you want to check it out, it's at Gossamer dev chainsafe.io. Should be in the document. Cool. Okay, so awesome. Okay, so bit of bumps there, but cool. So this part, it will be the final section. So this is running Polkadot Orcus on the full node. So I'll make this bigger again. Okay, cool. So yeah, so earlier I showed that you can run the dev chain with chain dev. So if you want to run the Polkadot chain, for example, you would run the node with chain Polkadot. So I'm going to just do chain Polkadot, and then I'm going to reinitialize it because I already had it running. Okay, cool. So I'm just going to start that up again. And then it should start syncing Polkadot. Okay, starting. So sometimes it takes a second to kind of bootstrap to the network. Should start soon. Okay, cool, here we go. Okay, yeah, so you can see it's starting to sync. Got that sync speed, got that number of blocks it imported, that kind of thing. And then if you want, you can also see the node on telemetry to get the details. So when our node starts, it makes a random name similar to Substrate. You can also specify the node's name with the name flag. Or yeah, we're doing the config. So our node's name was, where is it? Our node's name was, oh, here it is. Glide Flip. Okay, so our name's Glide Flip. So I'm gonna go to telemetry. So yeah, this is just telemetry.polkadot.io. Shows kind of what the nodes are up to. So I'm gonna find, yeah, so here's my Glide Flip. Clicked on it, pin it to the top. Cool, so we can see, this is my node. It shows I'm in Toronto. It shows the Gossamer version. And then this is the peer count here. So we have 39 peers, 40 peers. And then, yeah, we can see that now we are syncing. And then this is our average time to import one block, I believe. So yeah, cool. So if you let this run for a few days, you'll reach the head of the chain, and yeah, and then you'll have a Polkadot full node. So that's exciting. Oh yeah, I guess another thing to mention is that by default, Gossamer is an archive node, so it stores all the data from every block. It doesn't prune anything. So we have a pruning subcommand you can use if you decide to run a full node and there's too much data. So there is a prune state subcommand to clean up the state. Then we're also currently working on getting online pruning similar to Substrate working, so that you can just run the node and it'll just prune as it goes. Cool. And then I'll just show the same thing for Kusama. So it's the exact same thing essentially, except you put chain Kusama instead of chain Polkadot. Okay, cool. So I'll just run that. And what's our node name? Oh, chicken liquid. Okay, that's kind of weird. Okay, so we'll go to Kusama and then wait for it down here. Okay, cool. So yeah, so here we go. It's same thing. Toronto Gossamer node. Got some peers already. Yeah, we're syncing some blocks already. So that's nice. Yeah, so essentially same thing. Just wait a few days and it should sync. It'll take a bit longer for Kusama because it's around 2.5 million blocks higher. But yeah, give it a couple days and it should get there. Cool. Okay, so yeah, that's essentially it. Yeah, hope everyone enjoyed this workshop. Yeah. And yeah, if you have any questions or want to talk about Gossamer or any other sort of questions, feel free to email me. My email is elizabeth@chainsafe.io. And then our GitHub, if you want to check out the repo and contribute, we like contributors. So it's just ChainSafe, github.com/chainsafe/Gossamer. So yes, this is the repo. Yeah, feel free to check it out, look at the code, look at the issues, that kind of thing. Awesome. And then, yeah, I guess last little shout out is ChainSafe is hiring. So if you want to work at ChainSafe, please message, please email at info@chainsafe.io. Cool. Okay, so that's all for my presentation. Hope everyone liked it.
Thanks so much, Elizabeth. That was really cool to see. All the things that Gossamer can do already. It's made a lot of progress, and it's really great to see. We do have some questions, so I'm gonna get to some of them. Oh, bunch more came in. With Gossamer, is there any framework or way to develop runtime modules in Go, or is that only done via importing Substrate modules existing already?
Yeah, so right now, yeah, there isn't really any way to build runtime in Go, just because there's limitations right now of Go compiling to WASM. So we've kind of been exploring the possibility of doing this in the future by potentially using TinyGo, for example, which is which can compile some subsets of Go to WASM. Yeah, but it seems like at the current time, it's not really developed enough for us to develop that. But I think hopefully in the future, when it's more developed, we're definitely would like to create a Go runtime module library. That would be very cool. But yeah, at the moment, it's just Frame, or I believe there's also an assembly script library you can use for building runtimes. Yeah.
All right. Are implementations of Babe Grandpa consensus and Go part of the framework? If so, do they have a defined interface, and would it be possible to swap them out to use a different consensus algorithm?
Yeah. So Babe and Grandpa are part of the host. Yeah, so they are built into Gossamer. Yeah, so if you want to use a different consensus algorithm, yeah, you could theoretically just switch it out. We've tried to make Gossamer more modular so that, yeah, each feature So yeah, each feature like this tree, like the state tree, the runtime executor, all that kind of stuff is modular. So you could, yeah, ideally you would be able to swap it out somewhat easily. We haven't tried it, so there might be potentially some issues, but we've tried to hopefully make it modular so that you could, yeah, use different libraries if you want. Yeah.
Okay, cool. One more question, which is, it says, great work. Have any performance benchmarks been done to compare against the Rust implementation? I know it's early, but have any benchmarks been done?
Yeah, so we haven't done like super hard benchmarks, just kind of, I don't know, just benchmarking like as we go, kind of as we develop, to make sure stuff isn't like way too slow or anything like that. So I think in terms of, for example, like sync speed, so Gossamer, yeah, Gossamer only runs as an archive node right now. So like you saw on my computer, it's probably like 15 to 20 blocks per second kind of thing. If you have like a really nice, like newer machine, it can be like 30. If you run a substrate archive node, I believe at the beginning it's pretty fast. It's faster for substrate at the beginning. I think it's probably like 50 blocks per second. But then as it goes on, it sort of evens out and becomes like 30. So I'd say Gossamer is a bit slower in terms of sync speed right now, but not too much worse, not like orders of magnitudes worse, but we're hoping to get it up to the same speed as substrate. And then yeah, and then in terms of like memory usage, I think it's not as good as substrate. It's not terrible. It's like probably, I don't know, a few gigs, but it's, yeah, but substrate really is small just because it's Rust and doesn't have any garbage collection, so it's kind of nice like that. Yeah, so yeah, no hard benchmarks really, just kind of eyeballing it. But yeah, it's not too much worse than Rust, but we hope to make it on par. So yeah,
Sounds
that's kind
good.
of in our, once we get more of the kind of the functionality, like the authority stuff working, that's going to be our main focus, just optimizations and that kind of thing. Yeah.
All right, sounds great. Thank you so much for the workshop. Everyone enjoyed it, and see you at the next conference then.
Awesome, cool. Thank you, Phil.
Take care.
Yeah, take care.
All right, well, that wraps up all the talks we have today. I'd like to give a huge thanks to all the speakers who came out. Enormous thanks to the Web3 Foundation for hosting this event, as well as all the crew here for setting up everything, and in New York as well. So thank you very much, and from Berlin, this is Phil saying good night.